with fractions, there's a nice way of streamlining the process, so we want to definitely buy into that sooner rather than later. Order of operations so important. So parentheses, exponents, things like that. So we start with the innermost part of the expression on the left-hand side. We're looking at 4x plus 2 times the bracket 4 minus 2x minus 4 equals the right-hand side. You don't have to rewrite the right-hand side if you're not changing anything or you're not using it. We have a 4 and a negative 4. It says solve each equation. It doesn't say solve and justify your steps. But just out of curiosity, I'm canceling 4 with a negative 4. What property am I using? Additive inverse. All right, two numbers that add to equal 0 are inverses, additive inverses of one another. All right, so we're looking at 4x plus 2 times negative 2x. All right, so we're looking at 4x minus 4x. This is all equal to the right-hand side. Gives a result of 0. 0 equal to 2x minus 4. All right, next step. What do we do? Add 4, and then what do I do? Divide by 2. Add 4, divide by 2. All right, so we're looking at 2x equals 4, divide by 2. I'm looking at x equals, as a result, 2. All right, dividing by 2 on the right-hand side, that's an example of what property? You divide two numbers to get a result of 1. You can name it two possible things. If it's a property of equalities, a POE, it would be what property? Division. That's the simplest way of saying it, division POE. But we can think of 2 divided by 2 as the same as 2 times 1/2, giving a result of 1. 2 divided by 2 is the same thing. When you multiply two numbers in such a way that you get a result of 1, what are those two numbers called? Multiplicative inverses, exactly. All right. Got to get to know these names, folks. And if you do know the names, got to start participating. Right? In number 2, you could kind of take this similar approach to what we did in number 1. Add the 5/8 to both sides and go from there. I don't want to do it that way, and neither do you. What we're going to do is we're going to clear out the denominator. So extreme close-up. Whoa. Denominators. All right, so what I'm going to do is I'm going to multiply each part of the equation by whatever my denominator is. All right, so each part gets multiplied by 8. All right, so 7/8 times 8 is what? 7. 8 times 3n? 24n. And negative 5/8 times 8? Negative 5. All right, the reason we multiply everything by 8 is so that we change our fractional equation into something that's not a fraction or doesn't involve fractions. Much easier to work with the equation when you don't have fractions involved. That doesn't mean we're not going to get a fraction for an answer. That can happen, but this is nicer to look at. All right, next step. Add 5. So I'm looking at 12 equals 24n. Next step, divide by 24, yeah. So 12 over 24 reduces down to what? 1/2. And there it is. All right. So the only thing that would make this more challenging, I guess, would be if you had examples in which the denominators aren't all the same. It's not a case where you can just multiply by whatever the denominator is. In the case of, for example, number 4, so I'll do that one for you also. You still have to clear out the denominator, but this time I want to multiply everything by 12, yeah. So multiply by your LCD. All right, so each fraction gets multiplied by your LCD. So everything gets multiplied by 12. Some LCDs are easier to find than others. By the way, on the graphic calculator, on the TI, 84, it's the Lcm function. It's in the math menu. Under NUM, look for the option that says LCM. Actually, I can show you that real quick. The one drawback to this, and you did this with the caching exercise, it just didn't seem overly relevant or useful. It only works 2 numbers at a time, right? But we can actually make that work. You just have to pair them off. So if I want to, let's say I have absolutely no number sense whatsoever. But I do need to come up with the LCD. Then, oh, and by the way, the reason why there's a difference is because LCM, least common multiple, allows for it to not be a denominator of a fraction. So an LCD is an LCM that is specifically a denominator of a fraction. All right, so that's the only difference between the terminology. All right, so I go to math, NUM, look for the one that says LCM, option 8 apparently. Take the first 2 numbers. Well, actually, in this case, it's fine because it's just 2 numbers, 2 unique numbers, 3 and 4. And it'll report back what your LCM is. Now, let's say, for example, it was 3, 4, and this denominator was 5. What would you do? You'd find the LCM of the first 2 numbers, and then apply that to the third number. And you'd get an LCM for all 3. You can keep going with this. You could find the LCM of like 50 different numbers. But, again, all we need is 3 and 4. All right. So you can get it that way. The one drawback to that approach, I think, is pretty obvious. If you don't know where to find the LCM function in your calculator, or if you don't know that it exists to begin with, then that's completely useless. As a general rule, if you're looking for a function in your calculator and you can't find it, go into the catalog. That's second 0. Everything is listed in there alphabetically. It just might take you a little while to find it, but it's all there. All right. Now, what is 12 times 2/3 x, or 2x over 3? 8x, yeah. 12 times a quarter? 3. 12 times a third. Much nicer to look at than the previous equation. Now, we kind of have a pretty good sense of where to go from here. Add 3. And divide by 8. That's something that we can take for granted now. We've kind of beat that to death. All right, so let me show you another calculator trick. So this one's not for everyone. You may look at this and say, this is way more trouble than it's worth. I don't want to do it. And also, depending on the calculator model that you have, it may look a little bit different from what we have here, or what I'm going to show you, but it's actually pretty cool. And again, this one I was showing you the method that'll allow you to check your work. This will actually give you the answer, right? But if it's a fractional answer, it might be pretty ugly. So we have 2x over 3 minus 1/4 equals 1/3. This needs to get into the graphing calculator somehow. All right. Since we haven't really learned about graphing too much, I'm not going to take that approach. I'll use something else. Let me just. All right, so I want to clear out my denominators. What should I multiply each part of this fraction by?
6.
6. All right, that 6 is what? What is it known as? Common denominator in LCD. All right, so multiply by an LCD. All right, and so obviously I think that only becomes challenging if you have trouble figuring out what the LCD is. So 6's cancel, you're left with a 5x. 6 times 2 is 12. 6 times a third is what? 2. Now it's no longer fractional, so subtract the 12. You're looking at 5x equals negative 10. Divide by 5, and you get negative 2.
Could you have just subtracted by 2 at first? And
Yeah,
then
but I can get it for the rest probably.
You could, sure.
Wait, what?
All right, let me just show you something real quick on the calculator.